Hi everyone, I am SK Hima Bindhu, working as an assistant professor. Today I will be dealing with electronic measurements and instrumentation subject. Regarding this electronic measurement and instrumentation subject, this is the syllabus. The first unit is performance characteristics of systems. Second unit is regarding signal generators and analyzers. And the third one is special purpose oscilloscopes and bridges. Fourth unit is transducers and measurement of physical parameters. Fifth unit is virtual instrumentation. First of all, before going into the syllabus, first we'll know about what is meant by a measurement. In simple terms, we can say that measurement is nothing but where an unknown quantity is measured with an reference quantity. In technical terms, measurement is nothing but it's a process of determining the magnitude of a physical quantity by comparing it with the accepted standard unit, and we are expressing it in the form of a numerical value along with the corresponding unit. You all know that any measurement, for example, height, weight, everything, it will consist of two parts. Any measurement consists of two parts. First one is a numerical value. So the number that indicates how much quantity is being measured. After that, it will be definitely followed by an unit. So the unit is nothing but it's a standard reference used for that comparison. So for all the physical quantities, there will be units. So regarding this, we'll go depth in the when we are dealing with the syllabus. So only measurement plays a major role only in this digital era, or in how the measurement was going on in the ancient times. They used to measure the physical quantities, whether the measurement is there or not. In ancient times also, measurement plays a very major role, though technology is not there. Many instruments are also not there, but they used, with the available instruments in those days, in those times, they were used to measure the time they used to measure the time based on the position of the sun and the moon and the stars. They, by position of the sun, they used to go to the schools, or they used to go to the fields, and every work they will be they used to depend upon the position of the sun and the moon. Though they are not accurate, there was a system that they used to follow it, and they used to measure the ages also. How they used to measure the age of a person. In those days, they all know mostly 15 days. For every 15 days, we'll be getting Purnami and then Amavasya. By that days, they used to count by when the boy or a girl or any child is born. They used to measure that by putting the stones in a pot, and they used to collect all the stones and they used to measure the age of that person, and then later, once the death is happened, they used to throw that pot along with that person. That was one of the way how they used to measure the age of the person. Now they used to measure the time by the position of the sun, and is also by sand clocks, by sundials. Many types of measuring instruments were used, but they are not that much accurate, but they used to measure it. And they used to take in normal stones, and they used to weight half kg, 1 kg. They used to measure it. That was the thing. So by this we will note that measurement also plays a major role. Even though technology is not there, they used to measure the quantities. The only drawback was that they might not be that much accurate. So ancient civilizations measured time using natural phenomena such as movement of the sun, moon, and water flow. Some important ancient time measurement systems. Yes, measurement was important for trade. We require measurement for trade purpose and agriculture purpose, construction, and daily activities. Ancient people did not have modern measuring instruments like rulers or clocks or weighing scales. They used natural objects and body parts as a units of measurement. Even if you see ladies, those who are selling flowers, or even anyone, those who are selling flower sellers, if you go there, they used to measure with the fingers, and they used to measure in by using different body parts. They used to measure the things. So that is one way how they used to measure this, by using the body parts as the units of measurement. And length was also measured by using hand, spans, cubits, feet, and paces. We have observed about feet, 2 feet, 3 feet. They used to measure with the feet. Next, weight was also measured using stones, seeds, grains, and balance scales. Time was estimated by observing the sun, moon, and stars. So instruments such as sundials, water clocks, our classes were used to measure the time. Different regions followed different measurement systems and units. Lack of standardization often lead to variations and inaccuracy. The need for uniformity and precision led to the development of standardized measurement system used today. If you observe this, these are the different ways how they used to measure by using the body part with the fingers, toes, how they used to measure with the mostly for different purpose they used to measure. This is the ways how they used to measure in those days. Even nowadays also, if you go to the villages and some more places, we can observe this type of measurement. This is the sundial, where the position of the sun will be falling on this, and based on the shadow on that, they used to measure the by the position of the sun, they used to measure the time of this. This is by water flow. Based on the water flow also, they used to measure the time. And this is the sand. So in this sand dials also, by shifting the position of the sun, they used to measure hours and minutes. Those are all the measurements which were done in the ancient days. Now, what is happening nowadays, and what is meant by a measurement? So before going to measure, we require an instrument, whether it's an physical quantity or as an by any other quantities which are varying or fixed. So if you want to measure them, we want to use an instrument. So for that purpose, instrument. What is an instrument? We are surrounded by different types of instruments. We are measuring the time by wearing a watch on our hand. And now, what is an instrument? Instrument is nothing but it's a device which is used for determining values or magnitude of a quantity or variable through a given set of formulas. Measurement. So, what is the definition of measurement? In simple terms, it is a process of comparing unknown quantity with an accepted quantity, or unknown quantity with an known quantity. So what measurement tells? Now you came to know about what is an instrument, what is a measurement. So to measure, we require an instrument. So now what the measurement tells? Measurements tells about the property of something. So it's a process by which one convert physical parameters to meaningful numbers. So measurements can be done with the help of instruments like rulers, stopwatches, thermometer, weighing machine, etc. In engineering, measurement is a process or act or result of comparison between an unknown quantity and known quantity. In simple terms, we can define the general purpose measuring system. A general purpose measuring system consists of measurand, transducer, signal conditioning, and display. So these blocks represents a simple basic measuring system. So it consists of what? A simple basic measuring system should consist of a measurand and a transducer and a signal conditioning and display. So now what is measured? What is meant by measurand? Measurand means the quantity which you are going to measure, that is going to give is known as a measurand. And that later you are going to give to a transducer. It will convert one form to measurable quantity, and that is again given to a signal condition, where we can amplify the signal, filter it based on the requirement, and then we will be giving to the display. We'll learn about depth about this schematic diagram of the measuring system in the coming classes. So already I said that any measurement consists of two parts. One is unit of measurement and number. For example, human weight, it is 65 kg. 65 is nothing but say number, and it is followed with the unit. Any measurement consists of two methods. There are two types of methods, that is direct method and indirect method. Direct method means by doing some calculation, we will be giving the quantity and we will be getting the measurement. That is directly. Indirect method means after doing the calculations, for example, P equal to VI. So we have to calculate first current and then voltage. After that, we have to take the formulas and we have to calculate it. So after calculation also, we will be getting that. That is one way we are going to do it. That is not the indirect method. And even finding the resistance of an resistor, we'll be having B.B. Roy, Great Britain, very good wife. By using this, we'll be calculating that values, and we'll after the calculations, we'll be getting the resistant value. It will be getting in an indirect method. After some numerical calculations, we will be getting. In direct method, we will be giving the quantity, we will be getting the output. Now, that is the basic general block diagram of measuring system. This is a generalized block diagram of a measuring system. Here, if you observe, the generalized block diagram of a measuring system consists of measurand, a primary sensing element, and a variable conversion element, and a variable manipulation element, and a data transmission element, and data presentation element, and then a storage and a data storage and a display element. These are all the basic functions of an measuring system. In the basic measuring system will be consisting of transducer, measurand, transducer, signal conditioning, and display. This is a somewhat generalized. If you generalize that, the basic block diagram, where primary sensing element, after that conversion element, after that manipulation element, and then transmission element, and then presentation element. This, the name only indicates how the instrument will work. So these are the basic components of a generalized measuring system. So coming to the general, after going through the generalized measuring system, we'll be learning about the characteristics of measuring system. So coming to the characteristics of measuring system, these characteristics of a measuring system are helpful to know the performance of the instrument. So to know the performance of the instrument, they are of two types. One is static characteristics, another one is dynamic characteristics. So these are what is meant by static characteristics. Characteristics of quantities or parameters that do not vary with respect to time are called static characteristics. So in first part of the EMI, we will be learning about the measuring systems. After that, we'll be learning about the performance characteristics. Now, what are the different types of static characteristics? One is accuracy, precision, resolution, sensitivity, linearity, reproducibility, tolerance, bias, hysteresis, zero drift, dead space, range or span. These are all comes under static direct characteristics. Coming to the dynamic characteristics, the characteristics of the measuring instrument which vary with respect to time. Coming to the static characteristics that do not vary with time, whereas this will vary with respect to time, they are known as dynamic characteristics. There are four characteristics of dynamic measuring system. One is speed of response, another one is fidelity, third one is measuring lag, and another one is dynamic error. What are the characteristics of dynamic measuring system? You are now only speed of reference. As the name itself means how much speedily you will respond. That is not one. In the same way, since we are dealing with the instruments, how fast the instrument is responding when you are giving to a physical quantity. Okay, so it is a rate at which a measuring instrument responds to changes in the measuring quantity. So a good measuring system should respond quickly to the variations in the input. Higher speed response enables faster detection and measurement of standing parameters. And what is meant by fidelity? Fidelity is nothing but ability of your measurement to reproduce the changes in the measured quantity accurately without any distortion. So a system with high fidelity follows input signal faithfully. It indicates how accurately the output represents the input over time. In general way, what is meant by faithfulness or faithful? When a person will say faithful, so whatever you are conveying it, if the person will convey the same way, if they want to convey the matter without adding any other things, then we'll say that the person is faithful person. In the same way, so here if the signal you are applied without any distortion, you are getting the signal, that is nothing but we'll call it as an fidelity, where the measured quantity will be getting accurately without any distortion. Coming to the lag, already you know lag, nothing but delay. As the name indicates, it's a measuring lag. So measuring lag is nothing but it's a delay between the occurrence of change in the measured variable and the indication of the change by the instrument. It may cause due to, there may be delay. So why that delay? It can be due to mechanical, electrical or thermal inertia in the measuring system. So smaller measuring lag is desirable for accurate dynamic measurements. What is a dynamic error? It's a difference between true value and the value indicated by the measuring system is nothing but a dynamic error. It occurs because the instrument cannot respond instantaneously to the changes in the input. It depends upon the speed of response and the measuring lag of the instrument. These are about the performance characteristics of the instrument that you will be learning deep in when we'll start with the unit. Today we'll be going through the introduction of an EMI, what you are going to learn in electronic measurements and instrumentation. In first part, you will be learning about what is meant by a measurement, what is an instrument, what is a basic measuring system, and how nowadays the measuring instruments are there, and how the measuring instruments what they have used in the ancient times. Now coming to the basic measuring system and the characteristics, performance characteristics of the measuring system, such as static and dynamic characteristics, and how they affect the instrument. Now coming to the second unit, and this second unit you will be dealing with the signal generators. So this signal generator, as the name indicates, it is going to generate a signal. Which type of the signal? It is going to produce electrical signals, which of varying frequencies. So, okay, so in your lab, if I might have seen in your EDC lab or a PDC or in LICA, in all our electronic labs, there will be an CRO, and also along with that we require a function generator. It's nothing but a signal generator which is going to generate signals. So main purpose is here they are used for testing, troubleshooting, and designing electronic circuits and systems. There are different types of signals you have seen, like sine wave, square wave, triangular wave, arbitrary waveform, sawtooth type of waveforms. Different types of signal generators are there. But if you come to this, what are the different types of signal generator you are learning in this syllabus is, one is a function generator, another one is pulse generator, radio frequency signal generators, audio signal generators, and sweep generators. So what is the purpose of the function generator? If you want a single generator, just it will generate only one signal. Whereas coming to a function generator, it can be generating 2 or 3 types of a signal, such as sine wave, square wave, triangular wave, or sawtooth waveform type of signals will be generated. So where we can adjust frequency and amplitude. And pulse generator is there. This pulse generator will produce pulses with specific widths and amplitude, and these are used for digital circuit testing. And RF signal generators, they are operating at high frequencies, and they are used for testing testing the communication devices. What are the purpose of audio signal generators? They are operating within the audio frequency range, and they are used for sound systems testing. And sweep generators, this sweeps signals over a frequency range, and they are used for frequency response analysis. These are the types of the signal generators which you are going to learn in your second unit. In further coming videos, you will be learning about all these type of the signal generators. This is a function generator, and this is a signal generator, and this is an RF signal generator and an audio signal generators. Next part in the unit 2 only, the second part consists of signal analyzer. In the first part, you have learned about signal generator, which will generate a signal. Now, how to analyze that signal? So now there are instruments which are used to measure and analyze and display the properties of electrical signal, and that type of that will be analyzed with an signal analyzer. So what is the main purpose of a signal analyzer? Means it will evaluate the signal quality, identify the distortion, and ensure compliances with standards. Now there are different types of signal analyzers are there. So one is spectrum analyzer, which you will be observing this type of instrument in your communication labs, in your ADC lab. And next one is oscilloscope. Network is a network analyzer. Next one is logic analyzers. So coming to this spectrum analyzer, they are used to display signal power across frequency, and they are used for identifying interference and harmonics. And what is the block diagram? And what is the principle, how it works, and applications that we'll be learning in the coming videos. Next, regarding the oscilloscopes, they will measure any type of signal. They will display the signal with respect to time domain, whereas this another they will display signal in frequency domain. So these are all used for observing the signals and in order to measure the time and amplitude of the signal. Signal will be generated by a signal generator, and that signal generator we are going to connect to an oscilloscope. Always function generator It will generate the signal, but you can't see the signal of different amplitude and frequency. You can generate it, but that probe should be connected to an CRO in order to display that signal and to take those parameters of that signal. Next one is network analyzer. You will be observing this type of network analyzers where they are used to measure for S parameters in microwave labs. And logic analyzers, they are used to capture and analyze digital signals, and they are used for debugging digital signals. What are the applications of signal generators and analyzers? First one, they are used for communication systems. They are used in circuit designing for debugging and verifying circuits. They are used in audio systems. They are used in radio frequency systems, and they are used in education and research purpose, where when we are doing with research, definitely we have to test the signals. We have to we require an experimental validation. So signal analyzers and signal generators plays a major role even in research. These are all the different types of signal generators. One is signal analyzers, signal spectrum analyzer, harmonic distortion analyzer, and logic analyzers. Their block diagrams, applications, advantages, disadvantages, everything we'll be learning in the coming classes. Now, the third unit will focus on oscilloscope. What is an oscilloscope? Yes, you have seen this oscilloscope. In a simple way, you can conduct like a torchlight. Okay, inside an oscilloscope, there will be an CRT tube. Yes, so oscilloscope, it's an electronic tested instrument. The main purpose is to visualize the signal. So how you are going to visualize the voltages or currents of a waveforms, all those will be visualized on a screen, and it plays a major role in electronics, engineering, physics to troubleshoot and design circuits as well as to measure various signal parameters. Simple way we can say that oscilloscope is an instrument that displays electrical signals as waveforms over time. So it will always measure signals in time domain, voltage versus time display, current versus time display. So what are the key components of an oscilloscope? It requires a probe, a vertical system, and an horizontal system and display. That, coming to the internal block diagram of an CRO, we'll be learning in third unit. These are the different types of oscilloscopes are there. Analog oscilloscope, digital oscilloscope, storage oscilloscope. Again, we are having dual beam, dual trace too. So that you will be learning in the other classes. Okay. Next unit will be focusing on bridges. So bridges are the electrical circuits which are used to measure unknown resistance. There will be low resistance, medium resistance, and high resistance, and we'll be dealing with capacitive resistance, inductive type, and different and impedances. Different types of bridges are there which are used to measure the unknown resistances. They are characterized into two types. One is AC bridges and DC bridges, and this depending upon the type of current they use for the measurement. DC bridges will operate with direct current, and they are primarily used for measuring resistance. The most common type is Wheatstone bridge, and AC bridges will operate with alternating current, and they are used to measure unknown capacitances, inductance and impedances and frequency, which we'll learn by drawing the circuit diagrams, and we have to go with the derivation, we have to go with the balanced condition, and then we will be doing with this DC and AC bridges in the coming classes. Next unit will be dealing with virtual instrumentation. So the virtual instrumentation best example is nothing but LabVIEW. Okay, where what is an virtual instrumentation is nothing but where we will be dealing with both hardware and software. Here, in case of this, the key components of virtual instrumentation is it acts as a central process unit for data acquisition analysis. It includes a powerful processor, memory, and storage, and it requires a software platform. So it allows customization and user interface design. What are the popular platforms? LabVIEW by National Instruments, a graphical programming environment, MATLAB and Simulink. Python with libraries like PyVisa, NumPy, and Matplotlib. See here, we can design any circuits required by using this softwares, by using the software platforms instead of wasting the money. So before earlier, we used to place all the circuits on the PCB boards, and uh, after that the circuit is connected. If there are any, if it is not working, whole the circuit will be damaged. In order to avoid this, software platforms plays a major role where you can drag all the components which are there in the software platform provided, and you can design a circuit. If you have a good idea, or you are able to design any circuit, you can design it and you can test it. Then only after that only you can go for a real time, and then only you can frame that circuit on the PCB boards or Arduino boards. Last one is biomedical instrumentation. Biomedical instrumentation also plays a major role in instrumentation, where biomedical instruments are very much useful in order to measure the heartbeat, okay, brain activity, and tissues. So instrumentation is not only required in engineering, physics, and research, okay, they are also required in medical field also. So that's why biomedical instrumentation is evaluated as a separate branch in instrumentation. So there are different types of instruments are there. Only a few we will be discussing about this. Electrocardiograph, which will measure the heart's electrical activity. Electroencephalography, which will monitor the brain activity. MRI, will be listening this MRI scanning. So magnetic resonance image, detailed images of soft tissues. These are all the units which are you are going to learn in electronic measurements and instrumentation. So the depth of that every unit will be you will be learning in the coming videos. Thank you.